Okay, ladies and gentlemen, let's talk about graphing quadratic equations. Yesterday we kind of skimmed the surface, and today we're going to go just a little bit further than we did yesterday. So these are the steps to actually graph. Yesterday we did a sketch. A sketch is just a drawing without anything very specific. Today we're actually doing the steps. So first thing you have to do is find the axis of symmetry. Remember, that is an equation, okay? X equals. Yes, we're making a line on our coordinate plane, and lines are equations. Then you're going to find the vertex by replacing the x value into the original equation for x and find y. Then you're going to choose 4 values for x and find y for all 4 values. And then we're going to graph. Let's get started. So y equals x squared is the parent function. Would you please write down in your notes next to the problem that says y equals x squared that is the parent function. Okay? Parent function, meaning that is the simplest function of quadratics. When we had a parent function for linear, it was y equals x. Well, this is y equals x squared. All right, so the first thing we have to do is we have to find the axis of symmetry. And I told you to write it down every single time you're finding the axis of symmetry. So on your paper, I want to see x equal the opposite of b over 2a. All right, so I always identify what a is and what b is. I don't need c this time. I will be needing c soon, but just not today. All right, so a is 1, but look there is no b, there is no c, so b has to be 0 in order for x to go away. Okay, so b has to be 0. All right, so now let's go ahead and put it into our equation, and I have x equals negative 0 over 2 times 1. Well, we learned way back when that anytime I have a 0, all right, and I'm dividing by a number into 0, the answer is going to be 0. So 0 can be in the numerator, and obviously we can't have a negative 0, but I was just following the equation. So x is going to equal 0. All right, so now I'm going to plug x back in to the original equation for x to find y. Well, 0 squared, y is equal to 0 squared. Well, 0 times 0 is still 0. So my axis of symmetry, or excuse me, my vertex is 0, 0. So I always go make my coordinate plane, and now I'm going to put in the axis of symmetry at 0, and I'm going to plot the point 0, 0. So here comes my point, and the axis of symmetry is right on the y-axis this time. Remember that the axis of symmetry is a vertical line, and in this case it is x equals 0. All right, so now the next step said to choose 3, 4 points or so, 4 points. Remember that when we did lines, 2 points made a line, but 3 points made an accurate line. Well, 3 points will make a parabola, but 5 points makes a more accurate parabola. So we're going to go ahead and we're going to find 4 more points. All right, so here we go. I like to choose as easy of points as I can, and I like to go on the left and the right of my axis of symmetry. So I'm going to choose 1, 2, -1, and -2. You have to be careful. None of those points can be your axis of symmetry because we've already found the one point that's on your axis of symmetry, and that's the vertex. All right, so I'm going to put 1 in, and 1 squared is equal to 1, 1 times 1. So when x is 1, y is also 1. Okay, when x is 2, so 2 times 2 is 4. When x is 2, y is 4. When x is -1, now remember that I'm using -1 as an entire quantity, so it's -1 times -1. And again, that's going to be +1. And -2 times -2 is going to be +4. So let's go ahead and let's go graph those points. All right, I already have a 0, 0 graphed. Now I'm going to graph my points. Look at that. And look, if you notice, it's starting to look like an upward U. And I know that this is going to go upward, so I know I haven't made mistakes yet so far. I know that because remember, an upward parabola is that A is positive. And there's my parabola. Try not to make it a V. Remember, it does have a curved bottom. It is U. A V graph is a different kind of graph. We're doing parabolas. So there's my graph. All right. Now the domain is going to be all real numbers. How do I know that? Well, if I see the arrows are going at the top, and they're going on and on and on forever. Now think about it. If the arrows continue, they're going to keep going wider and wider and wider. The higher it goes, the wider that parabola is going to become. All right? And it's just going to keep going in both directions, wider and wider and wider. And if I kept going as far as I could see, then it would hit every x value that I could hit. But the range is different. The range, if you've seen I had here on the screen, is greater than or equal to 0. I left it up there because I want you to see why did I put that the range was y is greater than or equal to 0. Remember yesterday when I talked about the maximum value and the minimum value? And when it's an upward parabola, I have a minimum value. And the minimum value for y, I told you, was the lowest point for y. That means it has nowhere else to go but up. That means the range, all the y values, is going to be greater than or equal to 0. So the range is y is greater than or equal to 0. All right, so let's do this problem. Y equals x squared plus 2x plus 5. And I'm looking here. The first thing I have to do is write down the axis of symmetry. All right, and this is number 2 for those of you who are following along. All right, so now I have my axis of symmetry, and I'm going to find A, B, and C, or A and B, excuse me. All right, my A is 1, my B is +2. I'm going to put it into my axis of symmetry, and I'm going to get x is equal to -2 over +2 times 1, which becomes -2 over +2, which then equals -1. So x is -1. All right, when x is -1, what is y? Well, remember that's -1. I'm taking -1 times -1 here. And then I have 2 times -1 and 5. -1 times -1 is 1. 2 times -1 is -2 plus 5. And when I add 1 and 5, I get 6, and I take away 2, and I get 4. So my vertex is at -1, +4. All right, so here we go. There it comes where my vertex is going to be at -1, +4. And is it an upward parabola or a downward parabola? Well, I'm looking, A was a +1, means it's going to be an upward parabola, okay? And also my vertex there is at -1. Here we go. All right, so now what was the next step? Well, the next step was to go ahead and plug in 4 more numbers to find what the rest of the parabola looks like. All right? So now I like to do 1, 2, 0, and -2. Well, I have here that y equals 1 squared plus 2 times 1 plus 5 equal 8. All right? Now I'm going to plug in 2. Y equals 2 squared plus 2 times 2 plus 5 equal 13. Okay, so when x is 2, y is 13. Now I replaced here, last time you'll notice I had a -1. Well, I replaced that -1 with 0 because -1 I've already found. That's my vertex. So I'm now replacing -1 with 0. Sorry about that. So y equals 0 squared plus 2 times 0 plus 5. Y equals 5. Have you noticed that when we plug in 0, that everything goes away except for the constant? The constant, by the way, is your y-intercept every single time. Could you write that down, please? That the constant is the y-intercept. The constant is the y-intercept. Put it on the side of your paper or somewhere where I can see that you've written it. The constant is the y-intercept. Okay? All right, so now -2 times -2 minus 2, or excuse me, minus 2 times 2 is 4, -4 plus 5, and that is going to equal 5. All right, so now remember where we left off on the last screen, okay? This is where we left off. So let's go ahead and let's graph my points. Oh, look at where 213 is way off of my graph. I could do a couple of things. I could number differently. So instead of numbering by 1s, I could number by 2s. Okay, I could do that. Or, did you notice? I want you to look at the graph very carefully. Look at the points for 0, 5, and -2, 5. Do you notice that those are both just one space away from my axis of symmetry? Remember what symmetry means. If I folded it on top of itself, the points are going to line up. So that means that the point that I have here of 1, 8, notice that it is 2 spaces away from the axis of symmetry. All right, 2 spaces away. Do you see what I'm talking about? The axis of symmetry is there, so 1 space to the right gives me on 0, 8, 2 spaces to the right gives me 1, 8. So if I were to move and fold that axis of symmetry onto itself, I would have another point on the other side of the axis of symmetry. And in this case, it ends up being at -3, +8. And there is my parabola. All right, so remember what I said that the range was. The domain. The domain, again, that parabola is going to go on and on and on forever, both to the left in direction and both the right in direction. So that means at some point, all of the x values are going to be hit by that parabola. All right? So that means that the domain is all real numbers. But what is the range? Well, the range, again, it's an upward parabola, so my vertex is at a minimum. What is the y value for the vertex? Well, it's 4, and it's going up. So that means that y is greater than or equal to 4 is my range. Write that down, please. All right, so I'm giving you time to do this. I want you to pause the video and find the axis of symmetry and the vertex. When you're done, go ahead and restart the video. All right, hopefully you got -4, -1 for your vertex. So it means the axis of symmetry is x equal -4. All right, so now I want you to tell me what kind of graph is that going to be? Well, a is negative. That means it's going to be a downward graph. And so now I know that I have some numbers are going to be, it's going to be going down. So I would probably choose 0. And I would probably choose maybe -2. But remember, -17 is a very big number. So we want to keep our numbers somewhat low. I always like 1. 1 is a great number. But maybe if you did -4, you're going to see that maybe it's not going to be as bad as you think. So for tonight, I want you to finish number 3, please. So when I look at your work tonight, I want to see the entire page completed.